First of all, welcome everyone, and thank you very much for joining us today for this timely discussion or conversation on dilemmas of responsible use of data and algorithms for a digital society. My name is Wana Inel, and I'm a postdoc at Delft University of Technology. I'm really happy today to represent the responsible data science track of the Digital Society Research Program that most certainly you are all aware of by now. So, what did we do as part of the responsible data science track? Well, we focused on the development of AI-driven, human-empowering, social technical solutions that incorporate social, legal, and ethical aspects. We aim to have reliable and trustworthy AI systems, as well as to increase the visibility and impact of our research by making the digital resources findable, accessible, interoperable, and reusable. Besides that, we tried to get in contact with as many researchers and practitioners from a large variety of disciplines to get a better understanding of the field, to hear their concerns, to learn from responsible practices and also from success stories, and ensure that the data and algorithms are used responsibly. And with today's panel, we actually continue this discussion by focusing on dilemmas of responsible use of data and algorithms for a digital society, and by providing some actionable points in this direction. We'll focus on the technical aspects of the work, but we are also considering the social and ethical aspects. We'll touch upon issues around privacy concerns and people's rights to explanations, and understanding how algorithms take decisions based on data we as users provide. We'll discuss these points for about an hour. I should mention that we are very happy to take questions, so please let us know in the chat if you have any questions, and also if you would like to go live and ask the questions yourself. And with this, I'll just go ahead and I will ask our panelists to tell us a couple of words about themselves and about the work that they perform in the field of responsible data science or responsible AI. And I think I'm gonna start with the order that I see on my screen. So, Emily, please go ahead.
Yeah, hi, thanks everyone. So I'm Emily Sullivan. I'm an assistant professor at Eindhoven University of Technology, and I'm in the philosophy and ethics department. So my research is in epistemology and ethics, broadly speaking. And right now I'm working on a Vini project on the broad norms of explainable AI or explanations from machine learning systems. So those norms can be ethical norms, but also epistemic norms, like what types of knowledge should we require that we gain from these systems?
Thank you. Seda?
Hi, I'm Seda Gürses. I'm at the Delft University of Technology. I'm an associate professor there. I'm a computer scientist by training, but I'm in the Faculty of Technology Policy and Management. My work has in the last 10 years been very much about privacy enhancing technologies. With the rise of machine learning, I've been looking at the externalities caused by machine learning systems, and we looked at ways in which people can push back on these externalities with work on protective optimization technologies. And lastly, we understood that the political economy of big tech actually has a big effect on why we do machine learning and how the externalities will be dealt with. So I've been working on that over the last couple of years. Thank you.
Thank you. Carlos?
Hi, yes, I'm Carlos Martinez from the Netherlands eScience Center. The focus of my work is mostly on software sustainability, so on the reuse of software in the long term. And I think my focus on this panel is mostly on how do we make sure that the software that we use for machine learning, for creating machine learning models, remains usable and transparent in the long term if the machines and the tools that we use nowadays are no longer available in the future because technology moves on? How do we make sure that these things are still available and we still have access to the science that we're developing with these tools?
Thank you. Nava?
So I'm Professor Nava Tintarev. I'm a full professor at the University of Maastricht with a shared appointment 1 day a week with TU Delft. I work in explanations primarily in recommender systems. So I found the keynote just a moment ago very interesting on content moderation in terms of improving the transparency of the choices that are being made here. Last couple of years, we've been looking at viewpoint diversity and how we might represent that in a way that can be explainable to people in a way of representing viewpoints reasonably fairly. Thank you.
Thank you. Christopher?
Yeah, my name is Christopher Brewster. I'm professor at Maastricht's Institute of Data Science and a senior scientist at TNO in the data science group. My particular interest really is the application of data science in food and agriculture, which is relatively virgin compared to other industrial sectors in terms of technology. And so I am, from an ethical and responsible perspective, I'm very concerned as to what the longer term consequences are of digitizing a whole sector, both in creating dependence from people who have until now not depended on technology, and the wider environmental and social consequences of that digitization process in terms of carbon footprint and the use that is made of data that may eventually be collected or is being collected.
Thank you, Christopher, and thank you all so much for being here with us today. Now, I would actually like to start our discussion, and I'm going to invite Seda to tell us a little bit about the dilemma in her field. So a dilemma that she is facing regarding the responsible use of data and algorithms, and to tell us a little bit about what kind of action points we can consider to deal with such dilemma.
Thank you so much, Anna. And part of the reason I'm going first is I'm a little sick, so I'm not sure if I'm going to make it to the end of the session. And if I'm a little unclear, I blame it all on the virus. Okay, so the dilemma I want to bring is about fairness frameworks. And to get to my dilemma, I need to take a few steps back. So in the work we're doing, we're slowly showing that big tech does not necessarily make money from data and profiling and advertisement, but increasingly makes money from what we call the cloud and mobile era, which means that they make money by selling a lot of compute or becoming the default computational infrastructure for all sectors of life. So that's not just us in terms of entertainment or social media, but also for agriculture. Maybe Christopher will talk about that. Transportation, energy, health, education, whatever you think, they want to become the computational infrastructure. This means that as long as we're using machine learning, in a sense, we're making compute-heavy applications that increase our dependency on this computational infrastructure and allow it to expand. In that sense, the growing power of big tech is likely to increase inequalities, not only because they will become more and more economically and politically powerful, but also machine learning gives them a massive centralized tools from which they can assert policy, be it content moderation or what should be prioritized in transportation and how we should deal with agriculture, et cetera. However, industry has understood that inequality is part of the growth of their cloud mobile infrastructure through machine learning and have proposed a solution, which they call fairness. And as computer scientists, we've done a lot of work on this. Somehow all of our conferences are massively funded by these companies. And these frameworks say inequalities can be an outcome of the algorithms, and we should address these inequalities from the output of an algorithm by ensuring parity of outcomes for different populations. In doing so, we do three things. One is we reduce the inequalities produced by AI to the outputs of an algorithm. That means we don't look at its effect on the world, but just look at its outputs in the algorithm. The second and third thing we do is we give service providers a tool that says, please decide when there's no parity. And if you ensure parity in the output of one algorithm or multiples of them, but without looking at composition, then you're done with your inequality question. So in a sense, we have put inequalities at the discretion of service providers, allowing them to self-regulate. So my dilemma is, why are we continuing to work on fairness frameworks when it reduces our understanding of the inequalities caused by machine learning, which is a result of the cloud and mobile era? And how should we be training computer scientists to think very critically about machine learning, the machine learning tools, and how by applying machine learning, they're expanding the power of big tech and introducing inequalities, and how we can maybe think about other methods than machine learning, think out of the box to ensure we have good digitalization, but not necessarily with massive inequalities that are attached to it. Thank you.
Thank you very much. So now I would actually like to invite Christopher, simply because you had a little bit of connection among the topics that you mentioned. What do you think about this dilemma, and are there any solutions from your perspective?
Well, I think the first thing is, it's a very nice example that Seda is giving, because it's again reducing the problem back to a technological problem. So saying we will solve what is a social problem by technology, and this is perhaps one of the underlying issues that our whole of society is suffering from, is the constant belief that we can solve non-technological problems with more technology. So that's the first thing. The other thing is, we don't seem to be really talking here very much about power. And if you are the powerful person in the room, why would you be giving away more power? And that's really what we're talking about when we're talking about increasing equality or decreasing inequality. So there's a kind of contradiction here that we cannot within the systems purely solve the problem. Just within computer science, we cannot solve the problem at a technological level. We have to take a much broader, more integrative and multidisciplinary perspective. And we have to also be prepared at some point to talk about power and to talk about the fact that some technological choices are actually bad. And that raises all kinds of issues about freedom and who judges that and all those kind of issues. I'm not saying it's anyway easy. But historically, we have in the history of humanity made choices. We preferred some solutions, political solutions, to others. And there is, and as long as we can actually see that these technologies are political choices, not just technological ones, then we have a hope of actually addressing them in a constructive way.
Thank you very much. Next, I know that
somebody's got to disagree with me violently, please. Otherwise,
yeah, please, if you want to disagree.
Somebody disagree with me.
I was more thinking now in the direction of the work that Nava is doing. She's putting quite a lot of work in recommender systems, and she's taking different approaches to help people understand what the news items that they are seeing, what they are reading, and how they might reinforce their opinion. And I'm wondering whether she can provide us some new insights on how to deal with this kind of, let's say, fairness frameworks, or whether there are other alternatives.
Well, I really enjoyed Seda's point, and I think this notion of where the power lies also that Stephen was commenting. It's not just, of course, relative power of the different users, but the power between the platform and its users. In that lies a notion that the platforms are completely in control. And I also think that that's a bit of a strong assumption. I think there is a lot of pushback from policy and consumers that does shape the way that we're going. And my interactions with companies have also shown that, especially smaller companies, let's say, have maybe a different reaction. So that was just a thought on maybe the last two comments. When Seda first introduced the point, though, I was thinking in terms of what we've seen in research on auditing. So there are now a couple of researchers that are separately looking at auditing mechanisms of algorithms such as the filter bubbles on YouTube. And I think that is an exciting direction to go. Another interesting direction to go is that these fairness toolkits, at least from some companies, are in collaboration with academics. So the question is, of course, who is the gatekeeper in terms of what goes in and what gets used? Because just because there's a collaboration doesn't mean it gets used in practice. But I don't think that we've finished that dialogue just yet.
Thank you. Emily, would you like to add to the discussion?
Yeah, I mean, so one thing too is I agree with what Seda was saying, that we need to look outside just the output. But I mean, from my perspective, the output question isn't even settled yet on predictive parity as being the fair feature, right? So if you have base rates in populations that are different, like recidivism risk in the US, in the criminal justice system, the base rates between marginalized groups and white people are very different because of an institutional racism, right? So if you build a system of predictive parity on top of that, you're just going to be exacerbating these inequalities, but all of a sudden it's fair, right? So I think the problem is it's an even bigger problem, right, than what Seda is talking about.
Thank you. Well, Carlos, I know that as part of the eScience Center, you are collaborating a lot with academia. And I'm actually curious, how often do you work on these kind of issues that deal with fairness or in machine learning?
Well, actually, quite a bit. So we have a few projects that are based on machine learning, and that the aspect of fairness is something that I understand has been becoming more prominent in machine learning in general. So I think there has been a couple of projects, in particular one project about breaking filter bubbles, about how to make searches that can help users break away from their filter bubbles, and all these aspects of getting rid of implicit biases of these models. So there's quite a bit of interaction with academia in that sense, in this direction. And the other part that I was interested about, that was mentioned, about how the infrastructures have a lot of power because they control the platforms that we're using. And I think that's something where I think having more transparency on the models that are used, and having more transparency, a more open science, so to say, helps to break away. If it can make your machine models or the software that you're using to create your models platform independent, that you can easily say, well, you know what, I don't like Amazon anymore. I want to migrate my whole platform to use Google because they are more ethical, or because they give me a better price, or whatever. Or let's say, okay, now I don't want to use any of these private companies, but I want to move my models away and use the university's platform. And I think if our science is really transparent, and all of the algorithms that we're using are really open and exchangeable, and we can easily break away from platforms, that would increase actually the fairness of these models. That would give us like a lot of transparency and make us a lot more independent from the providers. And that maybe this is a mild disagreement with Christopher said, that the mild, not very violent, that it's a purely technological approach that I tend to take, but that might help to solve some of these issues that are of a non-technological nature.
I'm not against what you I mean, much of my work the last 20 years has been towards those kind of objectives. But the problem is, unless you impose that by regulation, it's not going to happen. You would have to impose a regulation from the state, from probably the EU, which would say systems have to be blah, blah, blah. And what that is, how we achieve interoperability and transferability of models and mechanisms and things like that. I mean, it's hard enough moving your email from one provider to another. And email technically is about the simplest thing you can imagine, right?
Yeah.
So, you know, that's my main objection there to start with, is that even as a purely technological solution, there's a very long way to go to make it possible.
Yeah, there I completely agree, because I think interoperability of any type of system, it's worst nightmare in computer science, right?
Right.
Even the text editors are sometimes non-interoperable, and it's like, come on, text is the most basic thing that we can have. Yeah, so yeah, there I agree. It's difficult.
Well, thank you. And if there are no other points on this dilemma,
I mean, maybe just to kind of quickly come back. So my work has unfortunately or fortunately turned to infrastructural power, because I saw my practice co-opted by it, right? And so it's very much about power all the way through. And it's also about the recognition that by now, if we want to do any compute heavy application that goes through also mobile phones, there's no way for us to do it for the phones without going through Google and Apple, and for the cloud without going through Amazon and Microsoft. And it's, you know, just think about, if you're teaching students, which tools you're using to teach them machine learning, and you'll probably already find yourself using frameworks provided by one of these companies. And so if we train computer scientists to basically use these tools, all I'm trying to say is that we're training them to build more machine learning with the growth, I mean, enabling the growth of these companies. And if we think that with explainability and fairness, we're kind of taking off the edges of machine learning, and the only way machine learning can happen is with these companies, we end up just serving the growth of these companies. So I'm just inviting us to think outside of the box about our training, even though I understand very much that this infrastructural power cannot be just constrained or thought differently by computer scientists. It also needs law and politics. And it's very interesting to see how they digest regulation, for example, right? Like there are lots of questions there. And I'm totally with Carlos that we need to, as computer scientists, think about what is an alternative that doesn't just feed this beast and allows us to have democratic societies that address inequalities in many ways and not just through fairness. Thank you.
Thank you very much, Seda. This is actually very helpful for me to go to our next dilemma. And I would actually like to invite Carlos to tell us a little bit about on this.
Yeah, so I think that it's basically, like you say, Anna, it's a connecting point. Because for me, one thing that we should focus on is in the transparency of the data transformation that we're in, and the data that is being produced by all the different types of data collection mechanisms that we have. We have the proliferation of sensors, of a new Internet of Things that produce a massive amount of data, and how we produce this data, how we process it, how we use it, and how we analyze it in order to achieve some scientific results, some conclusions. There needs to be transparency in this whole pipeline, from data acquisition to data storage, data processing, data analysis, and result publication. This whole pipeline of science, it needs to be as transparent as possible. And since a large part of this data processing is done through software, that's my focal point, that this software needs to be transparent as much as possible, and that the availability of the software that they use to make all these data transformations it's crucial for all our scientific pipeline in the long term. I mean, if we have a data set that in 10 years we cannot reanalyze in the same way, we cannot prove that this is correct or incorrect, that the data that we use, that was the science that we did 10 years ago, is that correct, or was there an issue on how we analyze the data? So for me, I think that as a scientific community, we need to improve how we approach science, how we practice science. We need to make sure that our data and our software is more transparent. So we need to improve our practice of science, sharing our code more, and that should be like a basic practice. Everybody is used to sharing their results by publishing paper, but we should also share how we get to these results by also publishing our code, and not just publishing our code, but making sure that when we write a paper, we write it in such a way that another scientist, another researcher can read this paper and can understand what is written in this paper. It should be the same when we publish our code. It should be documented properly so that the person who's going to read it is also able to understand what we're doing in this code. And even your future self, you should be able to understand what is it that I wrote in this code that I wrote 10 years ago. And that we should really increase the practice of making sure that our science is reproducible and that others can build upon our science in the long term. So I think that that's my call to action for people to really let's improve how we do science, by making it more shareable and more transparent.
Thank you very much, Carlos. I know that Emily, actually, she has a lot of interest in systems transparency, and I would like to know what kind of opinion she shares on this point.
Yeah, so my dilemma, it was about transparency, but we can wait to get to that. I mean, generally, I agree with Carlos. I mean, in the sense of like open science, right? That like even if no one ever looked at the code you put up or the data set you put up, right? There's something about the fact that it is open for people to see that maybe even makes the scientists more due diligent in their research. So I do definitely agree that that there should be complete open science and these things should be publicly available. I just wonder whether just being completely open about everything, just doing like a document dump, right, is able to cut through the kinds of problems that we see. Because there's a lot to go through, right? So like they say that if you were to read all the privacy terms on these websites, right, it would take you your whole lifetime to do so. So if everyone is doing all this kind of document dump, it's going to take us forever to go through all these documents. So there needs to be some other way that we can cut through all that noise. Yeah. I
wonder if this goes back to actually looking into other domains or other disciplines to see how others are basically, I don't know, going through large archives of data and how they can extract information that is relevant, how to present to users this kind of information. Maybe Nava has something to add to this.
So you're not going to get any dispute from me on the importance of explanations, of course. But I did see another formulation of your dilemma, and there was the comment of user recourse. And I think that's something that we often forget when we talk about transparency and explanations, that indeed just putting the information out there might not be enough when it's affecting people on the other end. So the question is, what is the capability the people who are affected by the systems to actually influence what happens there? Now, if they're programmers with sufficient programming capability and they can recode the software with enough knowledge, maybe that's not as big an issue, but for many end users, there isn't the case. And it's also a question of not only which data is there and trained on, right, and which biases are there, but which biases are there but not encoded in the data. So we see that in the fairness community, that there are things that are proxies for race or gender or other sensitive attributes that, while the sensitive attributes got taken out, the biases for the sensitive attributes actually do get implicitly encoded. So I think those are definitely things for us to keep watching out for as we build these systems.
Thank you very much. If you have something to add, please.
Yeah, with this thing about the biases being encoded, I would have thought that this is inherent to the nature of machine learning, particularly because basically you're saying future will be the same as history, and we learn on the history, and the history includes human biases. So that's why I'm very suspicious of the fair in the sense of just concept here as to whether it has any meaningful translation into actual solutions, because of this inherent design, if you like, of machine learning. And the other aspect here is somebody, I can't remember who, mentioned the use of machine learning in the American carceral system. There you have, you're pointing also to a fundamental problem, which is humans always will believe the computer and not their own eyes or their own instinct. And this is an additional layer of complicating, what role these technologies play in our societies, is the fact that they become oracles, they become godlike figures, even if we don't think of them as such, but that's what the way people behave. So they will believe the sentencing guidelines coming out of the software rather than their own opinion. So we have layer upon layer of problems here, which make it a very, very difficult set of challenges to disentangle.
I'm actually very happy because you brought this problem. Lately, we actually see this kind of shift where we say that we need to involve humans and users in the development stages of our AI systems, in testing, even for the design or prototyping. But how can we actually deal with these inherent biases? How can we make sure that we do involve users, but we don't inherit their biases? Is this something that is actually possible?
What do we mean by bias, really?
Yeah, it depends. I mean, let's think about recruitment processes, right? So before you had people looking through...
I want to recruit people like me, full stop. I'm not biased, I'm entirely objective.
Exactly, yeah. So it's also very difficult to understand what bias is and how it manifests. And I think there are many ways in which bias can appear.
Yeah, so I think a helpful way to look at it is that, at least in philosophy of science, they don't talk about it in terms of bias, but just value ladenness. So that these models are just laden with values. So, and that it's impossible to make them not laden with values. So there's always some values into the system. So then there's a discussion, there needs to be a discussion about what types of values are appropriate for these systems. So the kind of biases that people usually talk about are values that we find inappropriate for the system, right? So values that like promote longstanding racial inequalities or institutional racism or something that seems to be inappropriate to be manifested in the system. But maybe there are some values that are totally appropriate. So maybe the kinds of values that Nava's working with the diversity of viewpoint to make users understand the news they're looking at, whether it's reliable news, right? Those values probably are very much appropriate for the kinds of things that she's working on.
Thank you. We have a couple of questions in the chat. Okay, so there are a couple of questions for Seda, I believe. So the first one is from George, and he's asking the following. Would you give some hints for alternatives for computer data scientists that do not fit the beasts. Not computer scientists as private citizens, but computer scientists as researchers.
Okay, well, so that's $1 million question, first of all. What I was trying to do was trying to poke at the problem, right? Especially because, industry has done an amazing job of convincing governments to put a lot of their research money into machine learning and AI, because that's like the sexy marketing term. And also they have, immense amounts of cash, some of which has flown into research centers. There's now papers about this, comparing big tech to big tobacco, where research starts going into independent universities, coloring the kind of research they do and the kind of problems they ask. So this is not new, right? Any scientific and technological field has often looked and solved the problems of industry, because that's where the technology often gets deployed and developed. But I think we've really hit an extreme point here, where most of our research is becoming very monocultural, with machine learning as its main goal, without looking at where those problems are coming from and who they're serving. So I think I don't have like a quick answer, George, like here's what you should be doing research on, but here's some ideas. So I think we should be doing public interest computing research. And I think our funders should give us money to do that, and not just say do machine learning. That means, for example, if we're going to ask environmental questions, we don't think about how we can use machine learning to optimize what is left of the environmental disaster that we're in, but we think about how machine learning is actually fossil fuel technology and think about alternatives, right? Like, this is just very, very basic. And right now we're just continuously thinking about how we can enhance or enable the growth of current computational infrastructures as infrastructure of everything, which means it's really amazing. We're getting to build watches that remind you to breathe while they're burning compute with fossil fuels that are going to kill you. So it's, we need to kind of do research that helps us out of these crazy circles that we're working on in right now. I hope that helps.
And there is one comment also from Tarleton. So maybe we can leave this for later. There is a +1 for Christopher's point about bias. George says that sometimes we want the future to be radically different from the past, especially in situations where we strive towards increasing justice and dignity. Okay, so thank you very much for all the comments and questions that you had and answers also. And now I would like to move to Nava's dilemma and action point.
Sorry, just switching gears here. So another way to look at the explainability problem from my perspective is that also Tarleton talked about that in his keynote, that we're optimizing for certain metrics like accuracy, precision, recall. And I see this in an educational setting, which maybe is understandable until students know better, but I also see this in industry, right? So machine learning, traditionally, when you're doing well in these metrics. And my concern is that if, especially when we're looking at black box models, we're doing this blindly and actually hiding the kinds of errors that the accuracy is trying to avoid in the first place. So the example I'd like to give was shown by Rich Corona at Microsoft Research, and he was studying recovery from illness. I think it was pneumonia, and funnily enough, once they developed an explainable model, they found that patients with asthma were actually recovering or dying less often. And that's very counterintuitive. Why would people with asthma be less likely to die from pneumonia? Well, there's a variable in the data that's not represented, namely these are at-risk patients, and they go straight to the ICU. They go directly into intensive care. They get different types of care than other patients. So their increase in recovery has actually, has nothing to do with the variable asthma per se. So if you had a fully black box model adopting for accuracy, that simply would not be solved. So I'm wondering if indeed, maybe we should be looking at different sets of metrics, or even more broadly, thinking about what are the problems that we're trying to solve, and can they actually be solved by more inherently interpretable models where, yes, maybe they might perform 2% less on whatever metric, but are actually closer to what we're trying to get at.
Thank you, Nava. Maybe I would like to start with Carlos on this to give us the technical perspective on the dilemma.
So thanks, Anna. It's actually quite an interesting challenge now, because it's on the one hand, I think as computer scientists, we always tend to want to improve performance by 0.01%. Without actually taking a step back and looking what is it the problem that we're really trying to address, and or what is it the outcome that we should really be trying to achieve. So I think this is from the technical perspective, you will always want to have a faster, better, bigger machine. But it's almost more of a cultural challenge that we need to address. How do we change this mindset of I want the fastest result, the biggest machine, the more accuracy in my model or whatever, and how do we change this to say what is the better answer in a more qualitative way, I guess. So in a different way than measuring percentage. So I think getting metrics for these type of things is extremely challenging from the technical point of view, because it's almost more of a almost more of a social goal that you want to be able to measure. Is this good for society, this result that I'm getting? So I'm afraid as a technologist, I'm a little bit stumped. It's like, I don't know how to measure this technically. So that's where I think interdisciplinary collaboration with people, sociologists, with psychologists, it's really actually very important. And going back to what Anna mentioned earlier as well, keeping the human in the loop to try to optimize these things, to say, okay, yes, but is this a result that is actually useful for you as a human? That's where the challenge is, and that makes it incredibly challenging, incredibly difficult, incredibly interesting. So yeah, that's.
Thank you. Christopher, would you like to add something to this?
Well, I would draw a parallel with food. There's been a tendency in the last, since the Second World War, to go for size, quantity, speed of food production, whether it's the amount of wheat produced per hectare, or whether one can produce a loaf of bread in the Chorley wood process within 20 minutes or something like that. The consequence overall has been a degradation of the food system, damage to the environment, but also damage to human beings. So there's been a fight back, which is pathetic by comparison, but still it's an interesting way of looking at this problem, which is the slow food movement. There are many other variations that you could pick up on, but I'm proposing here a slow computing movement, where one would actually be looking at the quality of the computational process, the quality of the infrastructure, the quality of the results, and not the speed, the size, that sort of thing. Does the computing taste good?
Thank you. Actually, you can. Yes, Seda.
Yeah, I just wanted to kind of pick up on what Christopher was saying, and also relevant for Nava. We've been looking at fairness metrics as well, right? Like, how would you even apply them, given that most machine learning in application is kind of a supply chain, and there's, in the sense that, you know, somebody collects the data, another company pre-processes it, and maybe somebody runs some metrics on some of that pre-processed data, but then down the pipeline, all of those metrics might have no more meaning. And so I think it's very interesting to think again about like harms in terms of metrics, because it, on the one hand, completely erases the harms done in the creation of the data, anywhere from like exploitative labor practices, from labeling, right? Like the black box, there's a lot going on inside the black box that, regardless of the metrics, that can be harmful, that gets kind of thrown away. And the metrics also kind of gives you a quality of the machine learning pipeline, but not what happens afterwards in application. And then it's really hard to apply within the supply chain, where there are like maybe 20 or 30 different parties that have optimized different parts of the machine learning pipeline. And consistently applying this metric across that part of the pipeline is going to be very, very difficult. So I think there's one like application challenge there. And then the other thing is to think about, okay, what will the industry's response to that be? You know, we know from supply chains, you know, I don't need to say much about Rana Plaza, but it's very difficult to control supply chains. But what you can do with computing is you can control the environment more and more to make sure that the metrics are applied consistently. But I fear that that's going to be really problematic for all of those people who do not fit into what becomes really ossified in that machine learning pipeline. So the people who are anomalous or more likely to be in the error zone, et cetera. So I think this is like very fascinating questions about what it means to push metrics, be it for explainability or other quality metrics, as the way to manage the harms of these pipelines.
Thank you. And also regarding these black box systems, maybe we can move to Emily's dilemma and talk a little bit about transparency.
Yeah, thanks. Yes, this is picking up on one of the previous threads. So basically, the idea is that that pushes for transparency that can solve issues like fairness. It just kind of pushes the problem back a little bit, right? So it pushes the problem back because these systems are so complex. There's so much aspects of how they're working that you need to make choices about what aspects of the system you're actually highlighting versus other ones. So doing this kind of document dump, even if it is possible with some systems, it might not be, but even if it is possible, right, it doesn't really give us a meaningful way to really interpret what's going on. So we need to make choices about what to be transparent about. And the idea is that all these choices that we make are choices that are value-laden choices. And oftentimes it doesn't get discussed that these choices are value-laden. So really the action point is that to be transparent about the fact that these are the values that are going into this, right? Because a misleading explanation, even if it's strictly speaking true, can still cause people to mistrust or place undue trust into the system. So for example, one aspect was mentioned was the hiring algorithm. So whether using a machine learning model to determine who to interview or who to hire. So if someone's get rejected or if someone gets accepted for an interview, you could have a true explanation that talks about their educational background or something like this. But this might be misleading because maybe one of the influencing factors was the person's gender or race or something, right? And if that's hidden from the explanation, or you're not transparent about that, right, then it doesn't give people the right kind of recourse or something like this. So the idea is that we need to be clear about, well, what is it that we're looking for from these explanations? Are we looking for finding out whether or not discrimination is happening? And if so, that's what we need to be transparent about. Right? Do we want to be transparent about other aspects of the system? So it's really about taking a step back and asking, why do we want transparency? What is transparency for? And making sure that those values are encoded in it.
Thank you very much. I would actually like to connect your dilemma with Christopher's dilemma, because we are actually dealing with two different aspects. And I'm curious to know whether is transparency an important aspect when looking into agri-food or agriculture? Do we need explanations? If you can tell us a little bit about... your dilemma.
Transparency is something that the digitization of agriculture aspires to, but it's a particular kind of transparency. It's not the kind of transparency we're talking about here. Here we're talking about the transparency of understanding how a decision is made in a particular machine learning algorithm, and being able to judge whether it is biased in any particular way or value laden in a way that we disagree with. I mean, you know, I don't disagree with machine learning algorithms that allow me to hire people that look like me. I'm teasing, but still, no. In agriculture, the issue is transparency to share data across networks of food providers, food processors, retailers, etc. The dilemma I raised here was a slightly different one, which is it goes back to the issue of power. There are, data science is acting as a servant to power, and here there is a sector that has still not yet been penetrated completely by data science, although there are significant efforts to do that. And the dilemma I have is, assuming we get there in the next 10 years, are we then just laying the groundwork for the kind of consolidation that has been seen in previous information technology sectors? Tim Wu wrote this book, The Master Switch, where he explained how telegraph, telephone, radio, television, and other technologies always consolidated. There was a sort of a million flowers blooming to start with, and then after 10, 20 years, it all reduced back to just a handful of major players, which is what we're seeing with the internet today, with the big players that we are all complaining about. And certainly when somebody will come along and provide a completely disruptive technology which undermines all these players, that they will sort of lose their power. So that's my dilemma. Am I, being a data scientist, a handmaiden to further consolidation of a sector that would be actually seriously damaged by that consolidation?
Thank you very much. Seda, would you like to add something to this?
I think I have a question for Christopher to maybe explain a little bit more what that consolidation could look like, because I think, I really think that digital agriculture is really one of the terrains that's going to be hit pretty hard by the expansion of big tech in order to return on investment. And so I think it would be very interesting to hear about the different ways in which you think, especially machine learning and its application, could impact, I don't know, is it diversity? Diversity, not fairness, is something else going on here. Could you tell us more?
Well, I mean, historically, what's happened is as we've moved from a large number of small farms to a smaller number of big farms, there's been a huge amount of consolidation in the Netherlands in the last 20, 30 years, equally in Germany and most other European countries, not to speak of the rest of the world. What happens then when you get a bigger farm is that you get more monocultures and therefore less biodiversity, and you have therefore more negative outcomes from an environmental perspective. That's the pattern consistently across the board. You can see that if I start having farms which are instrumented with lots of sensors, drones, use of satellite data, weather stations and so on, monitoring what is going on, there is an inherent built-in tendency there to say, okay, scale will make it cheaper. I will have bigger farms, more data, have better predictive algorithms, therefore, for growing wheat. I will only grow wheat because I have the most fantastic algorithm. We already see a lot of consolidation for more classic monopolistic purposes in agricultural inputs. But I would see it logical that at every stage of the production, transformation, and distribution of food, we would see the entry or the consolidation of the big players, because more data will mean better tailoring of production, processing, and supply to customers. It's as simple as that, really. It's not a very sophisticated problem.
Thank you. I'm actually looking at the time and I see that our hour is almost ready, but I think we can take a couple of more minutes because we started a bit late. And in the time that we still have left, I would like to invite you all to tell us very quickly anything that you think is relevant to mention, but you didn't have the opportunity to do so far. And let's start with Christopher this time.
You want me to start?
Yes.
Well, I would make. I think it's absolutely essential that computer scientists don't work in a silo. I think it's really important that we have a much more interdisciplinary education and interdisciplinary approach to addressing the questions that computer science is trying to deal with, that data science is trying to deal with. Basically to educate ourselves and to educate our students more about the wider location of what we're doing and the consequences, intended and unintended consequences. Because it's only like that choices can be made both by ourselves, our students, and wider society that will actually move towards the use of AI for good rather than for unintended negative effects.
Thank you very much. Nava?
Maybe to echo some of the comments on reproducibility, this holds for accuracy metrics as well. Often we have these numbers reported for very different setups of the algorithms. So actually we're comparing apples and pears. So I think that holds here. But I'd actually like to close with, I have absolutely no issue with these metrics being in production. My issue is the blind use of them. So for me, it's a yes and. Let's use them and let's look at where they break. Let's use them and be aware of the fact that we're using historic data. Let's use them and see what happens when we use other metrics.
Thank you, Nava. Carlos?
Thank you. I think one thing that I like what Chris just said about having more diversity in the curricula, or that all computer science students should also have a little bit more of a background in cross-disciplinary research. And also I think the other way around, I think a lot of fields, given that our way of working is becoming more digital, I think all other fields of research should also have a little bit more of a basic understanding of computational approach. So I think that even every historian should have a little bit of understanding of what machine learning models do, to understand where is it that they might be going wrong, which implicit biases they might be acquiring. So just having like a little bit of understanding of how it works under the hood might help people use machine model algorithms better in the future. So I think it goes both ways. More more interdisciplinary training on all sides, I think.
Thank you. Seda?
Yeah, I think we should not put all our eggs into the machine learning basket. That's kind of my main message. And I think we need public interest computer science research. And I think to do that, indeed, we need to think about interdisciplinarity, but also avoid the monoculture of machine learning that is being promoted right now. Let's stick with that.
Thank you. Emily?
Yeah, maybe one other last point is that oftentimes you hear that you can just, deem a machine learning model as fair, or this has the right level of accuracy to then deploy it, but then it just never gets revisited. Right? So, but there's this idea, that you have to constantly revisit these systems, right? So this aspect of explainability, transparency, fairness, accuracy, these things aren't ever finished, right? It's something that we have to continuously look at and retool.
Okay, thank you very much. If you have anything else to add or question, please let me know. Otherwise, I would actually like to thank our panelists one more time for the fruitful discussion that they provided, and the audience for all the questions and comments, and for being with us today. And well, I wish you all a lovely rest of the conference. But actually, before we finish, there is one more thing that I would like to say. So as part of the responsible data science track, we actually took some time to analyze some examples that are very well known in the media, in research, where the responsible use of data and algorithm fostered inequality, inequity, prejudice, or produced unlawful or unethical outcomes. To give you a couple of examples, or to put you better in context, think about the algorithm published by Amazon for the recruitment purposes, the Compass system to see or actually identify which are people that are most likely to reoffend. And what we did, we tried to extract some requirements or needs. So what do we actually need to make responsible use of data and algorithms? And we did identify quite a lot of challenges that have been discussed today during our panel, and we put those in a document that we are aiming to publish very soon. And we look forward to hear your opinion and to let us know what you think about the document that we are planning to publish. And with this, yeah, thank you very much.
Thank you.
Thanks, Lana, for organizing.
Yeah, and all the other organizers
Yeah,
of the conference
yes.
too, all the technical people in the background somewhere. Thanks to all of them
Exactly.
too.
Thank you.